Namaskar and good afternoon, ladies and gentlemen. I take this opportunity to introduce Mr. Jubilan J. Kirkedodam, Session Chair. He pursued his bachelor's degree in the field of computer science and engineering from VMKV Engineering College, Tamil Nadu. He received his master's degree in the field of computer science and engineering from NITTE, Karnataka. He pursued his diploma in cyber law from Asian School of Law, Pune, and his master's in business administration in human resource management and marketing under Mahatma Gandhi University. He also pursued his PhD in Faculty of Information and Communication Engineering under Anna University. He have published more than 25 papers in international journals and 15 papers in national conferences. He is also an active member of ISTE, NIPM, CSI, and IEEE. He has won the Best Paper Award in National Conference on Distributed Computing conducted at NITTE. And I'm extremely delighted to welcome you, sir, for this session. Next, I hand over to Melvi Thomas to introduce the co-chair for the session.
Now, I take this opportunity to introduce Dr. S.G. Balakrishnan, Professor of Computer Science Department of St. Joseph College of Engineering and Technology, Palai. He received his bachelor degree in the field of computer science engineering under Periyar University and master's degree ME in IT with distinction under Vinayaka Missions University. He also received his doctorate degree in information and communication engineering under Anna University, Chennai. He has more than 12 years of experience in teaching and research. He has published 7 papers in international journals, 3 papers in international conferences, and 2 papers in national conference. His areas of interest includes cellular networks, object-oriented programming, and web technology. He worked with a depth of knowledge and tribute as a good personality with high integrity. He also delivered an expert lecture on web portal on the occasion of TechUp sponsored networking program Connected Society 2009 organized by the Department of Electronics and Communication Engineering at Government College of Engineering, Salem. He has achieved 100% result in all subjects handled and was awarded as Supporting Employee of the Year 2012 at VMKV Engineering College. We welcome you, sir.
So now we move on to the session, and for the session, the instruction for the session will be each participants will have a 20 minutes, and for the first 15 minutes, it is for the presentation, and the later 5 minutes for will be the question answer session. And then I hope the rules are clear for you. And so first, we will have the ID number Raerest CS 146, the paper entitled with an efficient resource management for prioritized users in cloud environment using Cuckoo search algorithm, presented by Anina and Alexander.
Very good afternoon to all. I am Anina Alexander, and I'm working as an assistant professor in computer science and engineering department of St. Joseph's College of Engineering and Technology. And my topic is an efficient using makespan. Makespan is the total execution time, computational cost, the deadline constraint with high CPU. So this is the fundamental concept of mobile cloud resource provisioning. These will be the mobile cloud consisting of all the mobile clients and their tasks. Each and every request will be considered as tasks like even and they will be connected to the internet either by using a Wi-Fi, 3G or 4G connectivity. And there will be a cloud manager, and this cloud manager is responsible for the overall conduct of this cloud system. So coming to my methodology. In cloud computing, the most inevitable part is data centers. Data centers are data centers. In data centers, computing resources will be allocated or it will be allocated as clusters. So in my proposed algorithm, I'm doing this clustering based on a density-based algorithm, where the capacity of the physical machines within a data center will be considered as a criterion of clustering. So for example, this entire thing will be your data center, and inside the data center, there will be different physical machines, and each physical machine will be capable of hosting a virtual machine. So what I'm doing is, I'm just clustering the entire physical machines within the data center into different clusters based on the capacity of CPU utilization. And after that, after this clustering, I'll be getting an underloaded virtual machine cluster, lightly loaded virtual machine cluster, and overloaded virtual machine cluster. After clustering, I will be getting underloaded, lightly loaded, and overloaded virtual machine cluster. In underloaded virtual machine cluster, the total load will be less than 10%. In lightly loaded virtual machine cluster, the total load will be between 40 to 10 to 40%, and in overloaded virtual machine cluster, the load will be greater than 70%. With these criteria, I have clustered my virtual machines. So, before allocating the load on the cluster, as I have already told, I have clustered it into three categories. And if the first category, if it is a first category virtual machine cluster, that is underloaded virtual machine clusters, that is utilization is less than 10%. What I will do is, I will migrate a task which is present in underloaded virtual machine cluster, lightly loaded virtual machine cluster, and I will put the virtual machine in these 50 LC each stage in order to increase the utilization and also to reduce the cost. So we are having two queues, LVM queue and OVM queue. So I will be maintaining a queue. The queue is known as LVM queue or lightly loaded virtual machine queue. And this queue will contain different lightly loaded virtual machines. So whenever a task arrives in a cloud, it will first go to a queue of scheduled tasks. That is, using some scheduling algorithm, the task will be scheduled in this scheduling queue. And from this scheduling queue, the task will be allocated to each and every virtual machine in this lightly loaded virtual machine. So, if the lightly loaded virtual machine queue is not empty, the dispatcher will remove the task from the scheduled queue and it will allocate that task to the virtual machine which is present in lightly loaded virtual machine. If the LVM queue is empty, it will check whether the global resources can host the virtual machine. If it is not possible, if both of these conditions are not satisfied,
Ma'am, that's not my question. That is, some when we look into least scores method, least cost. Okay. Time varying, what is it?
What's the difference between the clustered system and data center? Uh, Basically, what is the interface required for clustering? So all the systems should be within the data center only. The cloud means the services. Okay. Okay.
Any more questions from audience? Thank you.
Thank you. I just remind you again that each participant will have a warning bell after 13 minutes and final bell at 15 minutes. Okay, next, ID number Raerest CS102, the paper entitled Encryption of Reversible Data, Hiding for Better Visibility and High Security, presented by Sri Narayanan.
And there is a proposal system. Then I'm going to how it works and discuss on results, then performance analysis, then conclusion. After that, references I make. So this is the abstract. As the data encryption is the best method for providing secure communication. Secure communication is one of the major problem in nowadays life in both social media and networking, satellite communication, and also in medical field. So here the data encryption provide the better secure communication. The proposed method using reversible data hiding using a AES algorithm. AES algorithm is a new algorithm for data encryption. Then the goal of this proposed method is to combine the reversible data hiding with AES algorithm to provide better visibility of image and also high security. And after this proposal method shows a maximum data capacity of enhanced contrast. That means the image cover contrast is enhanced, and it will give more security for communication. So this is the problem in military field, medical field, and some forensic field. In financial field, we want to communicate in secure way. If it is in insecure way, there can be many data loss, cost loss, something like that can happen. So both data and our image is confidential. In satellite communication, there is a image. There is a chance for image can be sent from satellite to our receiving area. So if it is in confidential way, there is a chance for misbehaviors. So image and the data will be highly confidential. So there is no permanent distortion is acceptable. If it is acceptable, there is no need for communication possible way. So this the existing system use encryption method using DEs and AES only. So the proposed method working, first image encryption is carried out by AES algorithm, then data hiding is done, then we get the image with the reversible data hidden data. Then it can be decrypted with using the same algorithm AES, then we can extract both image and data in efficient manner. So this is the proposed method data flow. First we select the cover image. Then if we want to embed data, we take that embedded data and pre-processing that data. That means the selected cover image in grayscale image. So the pixel variation is from 0 to 255. So the pre-processing method is that convert all the 0 value into 1 and 255 value into 254. So then a slight difference can be made. And after that, take 2 peak values from that grayscale images. Taking that peak values and in that valued pixels embed the data. Okay, so if the image have 9 pixels, first is 0, 0, 0, 1, 0, 1, 255, 255, 255. Here we have 0, 0 for us and 3, 255. So these are the 2 peak values. We taking 255 and 0 for data embed. So after data embedding is done, we take the these 2 pixel value 255 and 0 in 8 bits mode, and that keep 16 pix model in last portion of the images. Then from that for decrypting, take the cover image and retrieve these 2 peak value from last portion of the image, and data extraction can be done. Then after we can extract both image and data in efficient manner. So this is the algorithm for AES algorithm. Take n1 character from f1, that means our image, and n2 from our key file. Then compare with that pointer. If n1 is greater than 2, just shift that key. Just shifting of key, then perform the algorithm. This is A XOR B divided by 256. This is the mathematical equation for AES algorithm. So this is an example for that. So our plain text is good morning. If an example, the ASCII code for both G, O, O, D and this manner. Then this take our just a key. This is the cover image. This is the pixel value of cover image. Sorry, ASCII values of cover images. If we done 71 XOR 64 divided by 256, we get 7. So there is other mode of data will be provided. It is in secure manner. This is the decryption. Take this ciphertext. So we take the same ciphertext for decryption and using the same key for the encryption also. After doing A XOR B divided by 256, we get the plain text in also in encryption. Good morning. We get the also the good morning. So this is the result. I am taking just example Lena for the image perception. This is the original image, and after 10 pair data encryption and also 15 and 20, this variation of image can be modelized. This is not visible for each pair of the contrast of the image will be increased. Okay. So this is the result I made in normal image data sets. In Lena Bridge, something like that. These images I get PSNR value, something like that. It's always in all images the PSNR value is above 48. It's a good result, and also the data capacity for each image is in this manner in bitwise mode. Okay, this is the result I got. Data capacity will more in bridge images, and also PSNR values also getting more in bridge values. So this is an aerial image, that's in satellite images. So take 8 satellite images. For those images I get also 48 above PSNR value and in good data capacity. So this is also plotted in graph. It's shown the same result in this table. Okay. This is in medical images. So medical images, there is some variation between 51 and 48, but it also give good PSNR value above 48 and also good data capacity. Also. So this is the PSNR with number of peak pairs of embedding. That is 10 pair we can, in 10 pair encryption we can add 30.1601 bytes in Lena and also other values in each images. So this is the plot between PSNR value with the peak pairs of embedding. That means in 10 pair we can give more data, in 55 we can hide reversibly data hide less data. In each iteration the capacity of data hiding will be decreased. So this is the bit per pixel value. For 10 pair we can add 0.3159 per pixel, and also increase the pair we can add more bits per pixel value in each image. This is the result I got. So in performance analysis, PSNR value for normal data set and aerial data set and medical data set is above 48, and it's a good result, and also data capacity will be in good manner. So we can, in medical images we can hide more data, because medical data images will be always in black or white. The grayscale image is not in fully embedded with the medical images. For even take an X-ray, we have sometimes we have 0 or 255. That means black or white. So we can reversibly hide more data in medical images. So I'm using dual core computer and for this purpose and 2G RAM and implemented in MATLAB. So I get this is from after the proposal method is work. So the execution time between file sizes, AS algorithm always the execution time is equal in all manner, but other methods are have more execution time when the image size is increased. So this is the number of maximum possibility in given by S raised to n, means the number of possible capacity of AS algorithm. So if take one value, means one pixel or pixel of one images, we have 1 divided by 256 comparison. That means ASCII values varying from 0 to 256. So we have 256 possible comparison between that. So the conclusion is that this method provide good result in security. Also reversibly we can effectively extract the data after reversible data hiding. Okay, in future work we can expand this algorithm level by true random generation instead of selecting key by the user. The reference I made. Complexity, I am doing talks around time complexity or space complexity, something like that. The complex proxy coming from that, which the key file is an image also. So the size of the image is increased. So there is a complex for that. We want to load the full image.
What do you mean data greater than 0?
Data.
The chart, that diagram. You are giving input value, no? You are checking whether data greater than or 0.
That means any value for hiding. If the data is greater than 0, means any value for hiding.
Actually, what do you mean data there?
Data means a reversible information. The reversible data hiding means hide the data in images.
Okay.
So that's the data. If you have any data, that is employed by data greater than 0. If there is no data, the data is 0. So there is no need for hiding that data.
And in graphs, why you didn't mention that XY plots?
For this.
X-axis and Y-axis. What is the Y?
So this is the x-axis with the different images.
Oh.
So for each different image, the data capacity.
So you have to give label, right? X-axis label and Y-axis label.
What all metrics you have used over in the measurement?
This is also PSNR data capacity. So the PSNR value is the error rate. So if you give the less PSNR values, there is a more error. So 48 near to 50 is good result.
Any questions? Thank you.
Thanks.
Thank you. Next, we will have the ID Raerest CS 148. The paper entitled A Study on Cost Effectiveness and Security of VANET Technologies for Future Enhancement, presented by Grishma S. Churail.
Good afternoon all. Today I am going to present my paper on a study on cost effectiveness and security of VANET technology for future enhancement. We all know that today we have lots of vehicles, increasing number of vehicles day by day, and also as number of vehicle increasing, number of accidents and also the congestion increasing. So traffic becomes one of the major issues in all around the world. So what we can do for that? First, we need to improve our traffic system. So at present, there are lots of methods for improving our congestion and also the traffic accidents. Like consider a scenario in USA. In USA, we all know that USA, the number of vehicles compared to our country, the number of vehicles are high in USA. So the congestion is also high in there. What they are doing is that they are maintaining a constant traffic speed of 200 km per hour. Thereby, they can reduce their congestions. And also consider the case in Kerala, our state. The government put a policy that they are fixing cameras in the roadside, and thereby the drivers get aware of that, and they can reduce the speed and can overcome the road traffic accidents. And inside the car vehicles itself, there is some security measures like seat belts, airbags, etc. But today, in this advanced world, we need advanced technology for improving our road traffic system. So, VANET is one of the advanced technology which is actually introduced for improving our road traffic system. VANET is a network of vehicles, and this vehicle can exchange information to each other. Like, consider a scenario that one vehicle which is facing a congestion, and that vehicle can inform other vehicles passing through that road and can send a message like don't pass or coming through this way here. I have facing a congestion and you have to reroute the direction. Likewise, that is one of the real world application of this vanet. But this vanet technology is possible, or for implementing the vanet technology, some more equipments are needed, and this is applicable only for expensive cars. So when we are proposing any idea, it should be useful for all users. So that is one of the limitation of vanet. It is only applicable to expensive cars. So by integrating a cloud concept, other vehicles having these equipments can share use of or make use of these resources from the cloud. That these are the existing systems, that is vehicular cloud, crown. In this vehicular cloud, what is happening in the resources of the vehicles that are in the parking lot or in the congestion, that time their resources are wasting, or they are wasting their time. In that time, the resources can be used, or other vehicles can make use of the resources of other vehicles, that the equipments available in the high expensive vehicles. That is actually happening in the vehicular cloud. In the case of crown system, the crown system which actually consisting of a RSU, star, and a consumer vehicles. The system consisting of three components. RSU is a roadside unit, that is base station. Base station means all the control is handled by the RSU. Star is any vehicle they wants to act as a cloud server, or any vehicle wants to give or share the resources to other vehicles. That becomes the star, and that star should be registered on the RSU. RSU have all the informations of the star, and one vehicle they want to use a resources, they should give a request to the RSU, and RSU will allocate the star according to the requirement of the requested vehicle. That is happening in the crown. But in these cases, in two situations, in vehicular cloud, the vehicle they want to, whenever the vehicle is in the static mode, that in that case, other vehicle can use the resources. So, Vanna Cloud, another concept, that is Vanna Cloud, it's a theoretical concept. They propose a new architecture. It consists of client layer, communication layer, and cloud layer. Here, there is only one cloud. In the previous cases, each vehicle acts as a cloud. But here, only one cloud, and all the vehicles can make use of that single cloud. So, that is this architecture. The client layer, which is the consisting of the vehicles, and cloud layer, that is permanent cloud and temporary cloud. Permanent cloud means that cloud can be used for storing informations, and the temporary cloud is SaaS, that is software as a service, infrastructure as a service. All these services can be used by other vehicles. The communication layer, that is the communication application, that is Bluetooth, wireless, all the wireless technology that is used for communicating with this client layer and cloud layer, that is actually coming in the communication layer. What I just did that I just made a comparison among these three techniques, and based on some parameters, that is quality of service, cost, resource allocation, and security. In the previous, this vehicular cloud, we need to authenticate each vehicles. We need to concentrate on each vehicles, and need to provide more security to each vehicles. In the crown, also the RSU, all the stars should be raised on the RSU, and we need to make more secure RSU. But in the case of Vanet, the security issues is very less compared to previous two things, that is vehicular cloud and crown. Only one single cloud, and we just only concentrate on that particular cloud. So security is low in compared to previous two technology, and also security is less in here, so cost is very less. And also here the resource allocation is happening like vehicles, they haven't or they wasting their resources like parking lot and in congestion situations, the resources can be available to other vehicles. In the crown, all the stars or which vehicle wants to give or share the resources, they have to register on the RSU. In that way, they are allocating their resources. So based on this comparison, I just conclude that VANET cloud is more better than vehicular cloud and crown. But even though there is much advantages in VANET cloud, but say we need to give more authentication or more security to VANET by using any encryption algorithm like that. So if we are implementing more encryption algorithm, we get a better VANET cloud, and we can make our traffic system more better in future. Thank you.
You discussed about some of the advantages of using VANET over other architectures, but do you find any disadvantages of using it? Yeah.
Actually, VANET can be implemented only for expensive vehicles. Like for implementing VANET, there is sensors, onboard computers, but these are only available to the expensive cars. So when we are proposing a system or any idea, that should be useful for all users. But here it is only useful for expensive cars. That is one of the limitation of VANET. That's why I using cloud. That should be, by using cloud, all the vehicles can share the resources from the cloud. That is.
So communication problem or something at the time of, I mean, since it is mobile, connecting with the clouds, maybe depending upon the geographical features also, right?
Yes.
So do you think that it's a drawback of using it?
By using VANET, in the case of VANET.
Yeah. Did you understand my question?
Please,
Means since the communication always, since the device is mobile, the communication will also depend upon the geographical features,
yes.
right?
In,
Where, yeah.
In VANET, each and every vehicles is communicating to each other. They are, whenever they are in the mobile or movement. In that case, each vehicle can communicate. That is this in VANET technology. Each vehicle having this technology have sensors or onboard computers. All the techniques are there. By
I agree. My question is very direct. That is, you told the implementation of cloud here, right? Since it is mobile, will there be any problem in connecting with all the systems with the connection problem depending upon the geographical situations? Because if you are moving out of the specific area or near field, communication is using over here, right?
yes.
If we are moving out of the specific area,
If we are
I feel in my knowledge, I think it's a bit tough to communicate with other nodes,
vehicles.
regular nodes.
We can make use of the base station also. If we are
Still, the communication should have to be done between the specific node and the centralized station or the server, which you told.
yes.
Means when you are my question is on discussion on the location where we are moving out of the field. That's one of the drawback, I think. Did you think of that?
Yes, one of the because the topology is varying, so there must be a drawback.
Any measures you identified to reduce the cost?
Reducing the cost. In the case of VANET cloud, we can there is only one cloud. So the security, or we need to authenticate only single cloud. So in cloud installation, for initial stage we have cost, but for further, if one vehicle want to use the resources, they can pay only for according to the use. In the case of cloud, thereby can reduce the cost in the case of using resources.
Any questions?
Thank you. Next, ID number Raerest CS132. The paper entitled Where AE is for Internet, Simon Could Be for IoT. Presented by Nitya R.
Where AE is for internet, Simon could be for Internet of Things. A very warm good afternoon, one and all. Internet of Things is upcoming era where millions of devices, say sensors, are being interconnected with each other and they can communicate with each other wirelessly. So we'll be looking into a block cipher, namely a lightweight block cipher, Simon, proposed by the National Security Agency uh, in the year 2013, which acts as a very strong alternative to the existing AES, the Advanced Encryption Standard. So why Simon? The obvious answer to it is Simon acts as a very strong alternative to the existing AES. The existing cryptographic algorithms are basically for the desktop computing systems. Now that we're moving into the Internet of Things era, there's a need for the resource constrained platforms. And that is the reason why we are moving on to the lightweight cryptography and thereby the lightweight block ciphers. Let's have a look at the basic cryptographic concepts. We'll have a look at the way in which the plain text is being processed. It is basically of two types, the block cipher and the stream cipher. And the block cipher, as we all know, is of two types, Feastal networks and the SPN networks, or the substitution permutation networks. The Feastal networks, as we all know, is as shown, and the plain text, the input to the plain, the plain text is divided into two parts, the lower block and the upper block. And the round function f is being happening on the upper block along with the key, and this is being XORed with the lower block, and this is being transferred to the next state upper block. And the present state upper block value is being transferred to the next state lower block value. And several rounds of processing has to go on to reach the cipher block. The reason why we are looking on into the Feastal network is the Simon, NSA proposed Simon is based on the Feastal mapping structure. The existing AES is based on the substitution permutation networks. As we said, the Internet of Things era is an upcoming network where millions of devices are being interconnected and they can communicate with each other wirelessly. It is actually the point of time where more devices are being connected to the internet than people being connected to the internet. So the need for lightweight block ciphers, as we said, we are moving on to the Internet of Things era, lightweight block ciphers. So there's a need for the lightweight block ciphers to dwell on few criteria, that is simplicity, efficiency, flexibility, and security. And keeping all these factors in mind, Simon was being proposed. So we'll have a look at the existing works of Simon in the form of a timeline. That is, in the year 2011, NSA, National Security Agency, actually started work on Simon. And the year 2012, they actually started to work on Simon, and they came up with the performance analysis of Simon. And they actually came up with the performance analysis of Simon in the ASIC platform. And they came up with a conclusion that Simon worked extremely well in hardware platforms and spec work extremely well in software platforms. And thus they concluded that Simon is actually meant for hardware platforms and spec for software platforms. And the year 2013, Simon and spec was actually proposed, and they came up with the design considerations, the round function, the key schedule, and all such design considerations. And in the year 15, Simon, NSA actually, NSA along with all such people actually, they proposed Simon and spec in all. They proved that Simon and spec could work in many hardwares, and they proved that it was very flexible. And the figure actually shows the Simon parameters, and it is actually Simon is actually flexible. That is, it can actually take up 10 different configurations. That is, it shows a flexible block size, key size, a word size, keywords, constant sequence, and rounds. The figure shows the Simon round function, the key generation. As we said, Simon is based on the Feastal mapping structure. That is, a plain text is divided into two parts. Round function happens on the upper block, and this is being XORed with the lower block and the key, and the newly generated value is being transferred to the next state upper block value. And the present state upper block value is being transferred to the next state lower block value. And Simon key generation is very similar to the round function. And this is a figure when the number of keys is equal to 2. And this is a figure when the number of keys is equal to 3 and 4. And this is a survey which is being conducted on Simon and AES in ASIC and Spartan 3 platforms. And the present work is, I took up one of the configuration, that is Simon 64/128. That is Simon plain block size is 64 and key is 128. And these are the corresponding parameters and the test vectors. And the test vectors are those provided by the NSA. And these are the simulation results simulated in Xilinx IEC design suite. And this is a Simon key schedule and the block cipher. And this is a comparison of Simon 64/128, the result analysis of a Spartan 6 FPGA and Z board. And this is that of in Cadence Synthesis RTL compiler. And future work has to be done in hardware, the Spartan 6 and Z board. Conclusion, we can just say that Simon acts as a very strong alternative to the existing AES, and it is very flexible.
So, excuse me, what's your work over here?
Sir?
What's your work here?
So implementation, implementation of Simon into lower technology board, Z board.
Did you display that work specifically in the presentation? No. My question is that we were discussing about, means most of the time, it was, I felt something a seminar like regarding the Simon. I didn't find any specific implementation pattern or your description of the work in the session here. I would like to know what work and how you have done in a detailed manner. That's what a presentation happens in a conference, right? Did you get my question?
Yes, sir.
So why don't you spend more time in displaying your works or I mean, discussing with your work? We're spending more time regarding giving us a feel that you are doing a seminar on Simon. Am I right or not?
Yes.
So can you tell a few words about your work in detail? What you have done here specifically?
So this is a block size. I picked up a configuration of Simon with block size 64, key size 128, word size is 32, keywords is 4, and constant sequence is Z3. That is a sequence provided by NSA. And rounds, number of rounds used is 44.
Okay, it's just implementation of something already existing
present.
existing system.
This is just this is being standardized, sir. It is not yet standardized.
My question is that what's your contribution over here?
Until now, it was not implemented in Zboard. It was just it is stopped in Spartan 6.
Okay,
I thought of
I think you are telling about you have done some present work here,
Yes,
but
sir.
you are just giving some values into it, right?
Yes.
Already existing system.
Yes, sir.
So that's something you are what here happening is that just utilizing a system already existing or application which is already existing, you are using it over here, right?
In a different hardware.
Okay, so if it is so, if you are doing in a different hardware, what's its advantage, what's its performance, all this has to be discussed in detail. Should it have to be discussed?
Yes.
Why are you not doing it here? We are not here to get means in an international conference when we are coming, we are not here to have a simple presentation or a seminar on a topic. We are just coming over here to discuss about something you have done, and that is how you are getting more knowledge. We ourselves discussing it, and the audience here are also thinking of the same thing. So you will be getting more suggestions regarding that, and that's how we will improve ourselves, I think. Okay, so that's what makes a difference between a seminar and a conference. Here, if you explain something focusing on the work you have done, that makes something different, right? And we are expecting that. So if you have that discussion on a performance or something like that, means advantage of using this on a new hardware, all those things, please spend some time for explaining it.
And that is until now, this is a performance analysis of Simon on ASIC platform, and this is a performance analysis of Simon and AES on Spartan 3 FPGAs. So as we see here, like area-wise, and throughput-wise, throughput is extremely larger for AES, and in Internet of Things era, we are actually we actually want resource constrained platforms where we are constrained in area, power, memory. So we don't want like we are concentrating on area. We don't want in applications where we want smaller area, like smaller areas, we can't use we can't use AES, so we can use an alternative such as Simon, which is very flexible. That is, we can make use of Simon 96/96 in place of AES, which has an almost same security. Thank you, sir.
Thank you. Next, we will have Raerest CS 147, the paper entitled A Study on Preventing Node Isolation Attack in Oil SR Protocol, presented you by Jeffin Liza James.
Good afternoon, one and all. I'm here to present my paper, a study on preventing node isolation attack in OLSR protocol. So these are the slides I will go through. First, I will introduce my area. That is, I am discussing on security issues that happens in MANET. That is, MANET is a wireless network, and the routing protocol used in MANET is a OLSR protocol, and this protocol is highly vulnerable to a type of DOS attack called node isolation attack. First, we will see a brief review on MANET. MANET, its expansion is Mobile Ad Hoc Network. It is actually a wireless network. It doesn't has a central authority to control it, and it contains a number of mobile nodes, and these nodes can come in and go out to in the network as it wishes, so that the network is highly dynamic. So we can predict the routing table routing in MANET. And now we will see the protocol that is used in MANET. It is the OLSR protocol. Its expansion is Optimized Link State Routing Protocol. It is actually the optimization of the earlier used protocol, that is the classical link state routing protocol. Its advantage over classical link state protocol is that OLSR is having optimization. That means this optimization is achieved using by reducing the duplication of messages that during the communication time period. And this optimization is achieved by selective transmission of messages. And this selective transmission is achieved by introducing a new concept called MPR, that is multi-point relays. Multi-point relays are a subset of one-hop neighbors of a sender node, and in the concept of MAT, there will be a node, and it has very next neighbors are the one-hop neighbors, and it has reachability to its two-hop neighbors. To communicate to the two-hop neighbors, it will depend on the MPRs, that is the subset of one-hop neighbors of that node. And two messages are used here, control messages are used here, that is hello message and the topology control message. Hello message of a node contains a list of one-hop neighbors of that sender, and TC message, that is topology control message, it is actually forwarded by the MPRs. And in TC message, it will list out the nodes that has selected that node as its MPR. Now we will see the attack, node isolation attack. It is a type of denial of service attack, and the OLSR protocol is highly vulnerable to this attack. And as the name suggests, in node isolation attack, a sender node is getting isolated by an attacker from the entire network, and this is achieved by sending a fake hello message to the victim node. And this fake hello message convince the victim node that it will be the most eligible MPR candidate for that node. So this is just an illustration of a node isolation attack. Consider X is the attacker and B is the victim, and X will send a fake hello message. It will also a unreal node called Effects, and it is used to convince the sender node, victim node. So three methods are proposed to overcome this node isolation attack. One is checking TC messages. Second method is using additional control messages. And third message is DCFN method, that is denial contradictions with fictitious node mechanism. We will see each of the methods. First one is checking TC messages. In this case, in the scenario of MANET, in this case of MANET, each node has the provision for checking its MPR's TC message and the hello message.
if there is no attack, the generation of TC message and hello message will be periodic. But if there is an attack, the generation of hello message is there, but the TC message generation will be blocked. It is because in the TC message, the MPR has to name the sender node. So other nodes in the system, in the manet will think that this sender node is there. So it will not it will not generate the TC message. So if if there is an attack, there will be no TC messages. The victim node can find the attack by if the victim node can find the attack by checking for TC message generation. If there is no TC message, it will understand that there is some attack. That's the first method. Second method is using additional control messages. Here, the genuinity of the hello message is checked, and here 3 additional control messages are used. That is to hop request, to hop reply, and not exist query. And there is another concept called one hop table. One hop table, it actually stores the hello message senders of a node and its corresponding two hop neighbors. This is an example of one hop table of a node A, and it lists out the hello message senders and its corresponding two hop neighbors. And we'll see how in this scenario the victim node will overcome the attack. If a hello message, a fake hello message is received by this victim node, it will first send the two hop request to all the two hop neighbors, and in response they will reply with the one hop table of that. It will return with the one hop table. If any of the one hop table doesn't contains that MPR candidate, then that node is considered as a attacker. So here there also one more method is there, using NEQ, that is node exist query. This is used to identify the existence of the unreal node that is used in the that is mentioned by the attacker node. If this NEQ is also sent to two hop neighbors, and if it has a positive response, then that node is real and it can be accepted as the the third method is DCFN method, that is denial contradictions with fictitious node mechanism. Here we have to consider 2 cases. First case is a usage of contradiction rules. There are 3 contradiction rules. First rule is like a victim node must confirm that there is no one hop neighbors of that node mentioned in the received hello message. Then coming to the second step, it must assure that there is the existence of all the nodes mentioned in the received hello message, and it must check whether it is at least 3 hop away from that that sender node, and it also checks it must check that whether that MPR candidate has appointed any other MPR to access that 3 hop neighbor node. And the third rule is for used as a precaution. Here the third rule suggests that the received hello messages with all the one hop neighbors of the victim node must be considered as a attack. Next we move to the next session, that is using fictitious node for finding the attack. This time a fictitious node, that is unreal node, is used by a legitimate, a true node. And when this is using this fictitious node, rest of the nodes in the network doesn't know this fictitious node is unreal. All other nodes in the system will think that this is real, and it will fix the legitimate cell as legitimate node as its sole MPR, but the attacker node will never set it as the MPR, because the only intention of the attacker is just to isolate the node. It doesn't want any communication with it. That's why it doesn't set the fictitious node as its MPR. So from this, a victim node can understand there is something malicious and avoid that MPR, that attacker MPR. So something that can be used to enhance the security of OLSR protocol is that making the nodes more authentic. So authentication can be implemented using inclusion of digital certificates. Digital certificates will be provided by trustworthy third parties. So this will this will make the nodes more reliable and more authentic. The situation is like the more authentic nodes are coming to the mannet, so the mannet will be more secure. So let me conclude. Mannet is a wireless network that and it uses the OLSR protocol as its routing protocol, and it is highly vulnerable to node isolation attack, which is a type of denial of service attack. And three methods are used to avoid this node isolation attack. That is the TC message checking, additional usage of additional control messages, and DCFN method. And the enhancement that we can do is making the nodes more authentic. Thank you. Yeah.
Requirement of three methods.
Each method is in a different deals the attack with the in different manner.
But you didn't explain that difference.
Okay, in the first method, that is TC message checking. Here, a node will so a victim node can check its MPR's TC message and hello message. The TC message will not be generated during the attack. At that time, it can understand that that node is not generating TC message, so it is malicious. That's the method of TC message checking. And in the next stage, next method, that is using additional control messages. In the first method, we are only using two control messages. Here, another three additional control messages are used. And it is actually using the routing table details of, that means a table, that is one hop table is used for checking the genuinity of node. And DCFN is totally a different method. The another entirely a fictitious and unreal node is used to identify the attacker.
The three methods you discussed, all those methods are proposed methods or existing methods?
Sorry?
All those methods are proposed methods or existing methods?
First two are existing.
Checking TC message.
Yeah.
Then using additional control messages.
Yeah, that is also existing. DCFN is working. Third method is.
That is also existing method.
No. It's not yet implemented.
Not yet implemented.
Yeah. But it's in a halfway.
Okay. It means the DCFN it's proposed by you or someone else?
I have taken it from a paper.
Okay. So then suppose you do not put DCFN under the proposed method, right? You can discuss any method, and your work is described. The digital certificates can be distributed inside the networks. So any questions from audience?
Thank you. Next, we'll have a tea break for 10 minutes, and the arrangements are made on the first floor of this block, just opposite the counselor's room, and the session will resume after that.
Welcome back. Okay, next we have the ID number Raerest CS154, the title entitled Monogamy Multiplier for the Faster Cryptome Systems, presented by Nida Thambi.
Good afternoon, everyone. Myself, Nida Thambi, PG Scholar at College of Engineering, Munnar. Today, I would like to make a presentation on Montgomery multiplier for faster crypto systems. These are the topics I would like to discuss. Then, as you all know, encryption is becoming an important part in our day-to-day life. It has many applications involving communication systems, network, and smart card, digital card, and also it has military applications. And modular arithmetic, modular multiplication is becoming a common part, a crucial part in most of this crypto system. An example for this modular arithmetic operation is R equal to AB mod N. Here we first calculate the multiply A with B and then divide the partial product obtained is divided using N. And finally we obtain the result obtained is the remainder value after the division operation. And to perform this modular multiplication operation, various other techniques are available, but Montgomery multiplier is widely used by most of the crypto systems. As I said, this modular multiplication operation involves both multiplication and division operation. Both these are the complex arithmetic operations. So, and also this modular arithmetic is a common part of this crypto system. So a faster crypto system, how speed a crypto system work will depend on how fast the modular multiplication operation is performed, and also the number of modular multiplication operation performed on the system. So the need of a high-speed crypto system motivated me in doing such a project. By developing such a Montgomery multiplier, we can provide a faster crypto system and also a safer crypto system, as the entire process of modular multiplication is made simpler and faster. Various other techniques are available for performing modular multiplication. And one of the papers I have referred says about the classical method of performing modular multiplication. That involves, if we need to compute AB mod N, then we first multiply A with B and we repeatedly subtract the N value from the partial product until the partial product becomes lesser than the modulus value N value. Since this involves this repeated subtraction technique, it will be complex and time consuming. And another paper says about the interleaved raw multiplication and reduction process. In this process, we mix, along with the multiplication operation, we do the division operation. That is, before calculating the final partial product value, we start the division operation. Thus, the time required for computation can be reduced. Modular exponentiation is another arithmetic operation. An example for modular exponentiation is a raised to n mod m. Here we need to multiply a value repeatedly n times and finally divide it with the m value. This is a complex operation and also involves multiplication reduction operation. So these time-consuming operations must be replaced by a suitable technique, and Montgomery multiplier is the best available technique. My objective is to design a faster Montgomery multiplier, perform the analysis of the same, and compare it with a normal Montgomery multiplier. As you all know, cryptography is the process of secret coding, and there are three main types of cryptographic algorithms. They are secret key, public key, and using hash functions. And based on the type of keys used for encryption and decryption, they are divided on this basis. This is the concept of cryptography. First, the plain text is converted into a cipher text using encryption key, and the cipher text is retrieved back at the receiver end using the decryption key. These encryption and decryption keys can be similar or different. If they are similar, it is secret key, and if they are different, it is public key. RSA algorithm is a major public key cryptographic algorithm. Here, at the encryption side, the cipher text is obtained by the modular multiplication operation. That is, message m is m to the power e mod n. Here, e and n are the public key or the encryption key, and at the receiver end, the original message is retrieved from the cipher text using decryption keys d and n, and this is called the private key of the receiver. To perform this operation, m to the power e mod n, we can use a Montgomery multiplier, and using such a multiplier, the entire process of the crypto system can be made simpler. Basically, a Montgomery multiplier idea is to reduce the result, the length of the intermediate result. This is done by performing the division operation with 2. Now, along with the multiplication operation, we perform the division operation using 2. That is, Montgomery algorithm computes x into y divided by 2 raised to n mod m. And thereby, the interleaving, we are performing the interleaving operations. The division operation can be can be done using a shift operation, simple shift operation. And as I said, modular exponentiation is a complex process, but by using this Montgomery multiplier, it is made simpler. The input values in the input domain, integer domain, is converted into a Montgomery domain, and the entire operation of modular exponentiation is completed in this Montgomery domain, and after the result is converted back into the integer domain. And this conversion takes place only once during the modular exponentiation operation, and to convert, we require only a Montgomery multiplication operation. These are the techniques happening in the Montgomery exponentiation operation. Here, input values are x, y, and m, which are n-1 bit values, and the result we need to get is z, which is xy mod m, and the inputs in integer domain, that is x and y, are converted into Montgomery domain by multiplying. X is converted into Montgomery domain x bar by multiplying it with x into 2 raised to n mod m. Similarly, y is converted, and finally the result we obtain is z bar, which is again in the Montgomery domain. So there is a need for us to convert back the result into integer domain. It is done by Montgomery multiplication using 1. And finally, we obtain the result z from z bar. As I said, Montgomery multiplication requires no hard division. Just by involving a simple shift operation, we can perform the operation. And to perform a Montgomery multiplication, certain constraints are needed to be satisfied. They are the multiplier values, input values must be less than the modulus value. Then m value, the modulus value must be odd. Then GCD, the 2 raised to n and m must not have any other must be co-prime, must not have any other common divisor. Then it also involves pre-computation of certain values. I've first gone for a normal modular multiplier that is using this repeated subtraction technique. But due to the shortcomings of this technique, I went for Montgomery multiplier that is using radix 2 algorithm. And to make the process much more faster, I have implemented a faster Montgomery multiplier using another algorithm. This is the radix 2 algorithm for a Montgomery multiplier. Here the input values are x, y, and m, and the result we need to compute is xy mod m. And z is initialized as 0 first, and the result is obtained after n number of iteration, where n is the number of bits of input x and y. Finally, after n number of iteration, the result z is obtained. So an example for this radix 2 algorithm. Here we need to compute xy mod m, that is x6, and y5, 30 mod 7. That is the result we need is 2. First, z is initialized as 0. Then after the iteration, n number of iteration. Here it is 3, and after third iteration, the result 2 is obtained at z. Major drawbacks of this technique are by using certain pre-computation of certain values, we can reduce the complexity and also the hardware required. So a lookup table based implementation of this algorithm is possible. So the number of addition operation can also be reduced. So another algorithm, which is the faster one. Here also the input values are x, y, and m, and the output we need is p. Here I have pre-computed certain values and is stored in a lookup table based implementation. So the values are stored and taken when needed. And finally, the result is obtained faster than the previous technique. This technique is simpler than the previous one. Although it requires certain pre-computation, the number of additions required in the process is reduced. So it is simpler and also a lookup table based implementation. Both this normal and fast Montgomery multiplier coding is done in Verilog and synthesized in Xilinx. Area and delay analysis of the same were performed. The result obtained are, this is for the result for a repeated subtraction technique and for a Montgomery multiplication, and then the faster Montgomery multiplier. Analysis results, area and delay analysis results are given. And from this delay of faster Montgomery multiplier is less compared to the previous one. So it shows that it is a faster one, gives a result faster. Finally, I've found out that Montgomery multiplier is simple and time efficient as the result is obtained faster. Then the power dissipated in the entire technique is reduced, and thus it is superior to the techniques which are currently available. And I would like to extend my project by implementing a system which can perform this modular exponentiation and then for FPGA implementation. Thank you.
What's your plan regarding implementation in FPGA?
I have not started it.
Just share your ideas.
I'm learning the board now, and also I need to make certain modifications. I'm planning to make a reversible Montgomery, in which the power dissipated will be less. So I'm planning for it. I've not started the FPGA implementation.
And we told about for advantages. Yeah. Do you find any disadvantages over the existing system when you implement it?
Area consumed will be little greater than the previous one since it involves storing of values. But in case of delay, it will be faster. Delay is less.
So this your Montgomery modular multipliers, which is implemented in which public?
Xilinx ISC.
You can do the comparison table. This faster Montgomery multiplier, which is implemented using
Xilinx, coded in Verilog and synthesized in Xilinx ISC suite.
Okay, and it is compared with any other public crypto system.
The previous one, normal Montgomery multiplier. Both these are compared, and the result is.
Then the normal Montgomery multiplier, which
that also I implemented in the same platform.
same platform.
Yes, Xilinx. Thank you. Thank you.
So now you will have the certificate distribution ceremony for the participants. As I call upon the name, the participants are requested to collect the certificate from Mrs. Julan J. Kirkithodam. The first we will have Sri Narayanan with the ID number Raerest CS 102. Next, we will have Anina and Alexander with the ID number Raerest CS 146. Next, we will have Jeffin Liza James with the ID number Raerest CS 147. Next, we will have Grishma S. Chirail with the ID number Raerest CS 148. Next, we will have Nitya Thambi with the ID number Raerest CS 154.
So here comes the end of paper presentation. As a token of love and gratitude, we would like to give a certificate to Dr. Jubilant J. Kirkithodam. So for that, I cordially invite Mr. Smita Jacob, HOD of CSC Department, to the dais.
Now I invite Ms. Smita Das for the word of thanks.
Good evening, all. I feel honored and privileged to get an opportunity to propose a vote of thanks in this occasion. Let me express my gratitude to our session chair, Dr. Jubilant J. Kirkithodam, for kindly accepting our invitation, even in his busy schedule, and also for his valuable comments. I also express my sincere thanks to Dr. S.G. Balakrishnan for being the co-chair of this session. I would like to take this opportunity to acknowledge the contributions of all those who have presented purpose at the conference, as they were willing to take the time to share their research and findings with us. Thank you all, dear participants. I'm thankful to all the student representatives who have helped in organizing the session and for being as audience. We remain grateful to all for being with us for this evening. It's been a great pleasure. Thank you very much.
Finally, one word. For the past 1 year, even though I am out of this department and the system, I'm really happy to be here and to be with you all. And again, from the bottom of my heart, I would like to appreciate all the efforts happening here from the college, from the department. I sincerely thank and appreciate Smita Miss effort and all the faculties and students' teamwork for making it a great success. Because, as you know, I've been participating in different conferences many times and many places. I think the standard and hospitality happening in SJCIT is surely commendable. Thank you.
By this, we have come to the end of the session. Last but not the least, I would like to extend my sincere thanks to all of you for your patient listening and kind cooperations. And we will have a photo session for the participants right now. And you will have the best service at 4 p.m. from the main block. Thank you and have a nice day.